Good day, everyone. I believe you people are doing well. So, let's keep on praying for our health workers as they keep on battling with this pandemic that befell us. So, as you all know, I'm Danladi. So, I'll be taking you physics on a topic: energy quantization. Energy quantization. As you all know since you are junior class, that matter is anything that has mass, weight, and can occupy a space. Matter is said to be made up of an atom. And from the work of the Greek philosophers to the work of John Dalton, so many people, so many scientists have been working, explaining to us the structure of what atom is made up of. Some of these scientists some of this work includes the work of J.J. Thomson, the work of Ernest Rutherford, and the work of Niels Bohr, and that of the electron cloud model. All these models, they are trying to explain to us what an atom is. So, our focus will be on the work of Niels Bohr, which gives us the idea of the quantized energy state of an atom as he used the hydrogen atom as his case study. So these are the postulates in which Niels Bohr brought up during his investigations on matter. His first postulate goes like that: the electrons move around the nucleus of an atom in a certain specific orbit or energy level. And as the electrons keep on moving around that energy level, the centripetal force always balances the electrostatic force that exists between the electrons and the nucleus. As we all know that electron is negatively charged and the nucleus is positively charged. So there exists a force between them, and that force we call it the electrostatic force. So the electrostatic force that exists between the electrons and the atom is always balanced by the centrifugal force. So as these two forces balance, as the electrons keep on moving in a circular path, it keeps on without emitting a photon. So the second postulate is that the energy of electrons in an atom cannot change continuously, but it can only do so in a quantum or in a quantum jump. It cannot lose energy continuously. Once the electron wants to lose an energy, it can only do so in a quantum jump. It can't do so continuously. That's his second postulate. Then the second postulate of Niels Bohr, which gives us the third postulate, is that the third postulate of Bohr was that the angular momentum value of the electrons in an atom are quantized. That is, they are restricted to a limited number of a discrete or a fixed value. That are integral of the multiple of a constant, which is given mathematically as the angular momentum L is the same thing as N open bracket. The angular momentum L is the same thing as N open bracket H all over 2 pi. So our L here stands for the angular momentum. Our L here stands for the angular momentum, and our N here stands for the quantum number, and our H stands for the Planck constant, while our pi, as we all know, is a constant. So that's the third postulate of the Niels Bohr. So in the first postulate of Niels Bohr, he stated it clear that The electrons move around the nucleus of an atom. They move without radiating or emitting an energy. Hence, electron in those atoms exist in a discrete or in a fixed or quantized energy state. So the energy of a momentum of a radiation or a photon, the energy of a momentum, the energy of a quantum of radiation or photon is given by energy is the same thing as h multiplied by f. Our E here stands for the energy of the photon that is emitted, and our h here stands for the Planck constant. Our f stands for the frequency of the photon of the light that is emitted, as being stated by a Planck's theory. So that's the first postulate of Nelbo, which gives us the basic idea of what we refer to as energy quantization. Now, before we go further, I would like us to know, what do we mean by the word quantum? A word quantum means a fixed or a discrete or a separate amount, while energy quantizations refers to a fixed or discrete amount of energy that is radiated when an electron moves from an excited state to a ground state. Now, this is the basic concept of what we mean by energy quantization. Now, this is electrons. This is the atom of hydrogen. This is the nucleus. So, assume that these are the energy level. These are the quantum numbers. So, this is the first shell. This is the first shell. We call it 1. This is the second one, N2. This is the third one, N3. And this is the fourth one, N4. So, based on what we mean by energy quantizations, is that when an electron, this is an electron of this hydrogen, when it absorbs an energy, it moves from what? It moves from a lower energy level onto what? The next one. It moves from the first energy level to the next one. So that's when it what? When it absorbs an energy. So when it absorbs an energy, so at this stage, this is not the exact energy of the electrons at its normal place. But when it obtains an energy, it jumps to the next level. So we call this an excited level. The excited level is always unstable. So once there is no more energy that is coming in, the electrons jump back to its original energy level. So it is during this jumping that it comes back to its original level. It used to emit a photon, and based on the study of Max Planck, he said that the photon is the same thing as E, which stands for the energy of the photon is the same thing as the Planck constant multiplied by the frequency of the photon. So that's the basic of what we mean by energy quantization. Energy quantization refers to that fixed amount of energy that is radiated when an electron moves from an excited state onto its what? Ground state. So, as I'm trying to explain it, once it gains an energy, it leaves this side, it leaves this energy level, and it jumps to the next energy level. But as it emits the photon, the electron jump back. So, this process is what we call the energy quantization. This is what we call energy quantization. So, atomic energy level is the next subtopic after this. Atomic energy level. So, electrons, as we all know, they are believed to be arranged around their nucleus in a position known as energy level or electron shell. Sorry, I just clean this. So electrons, as I've said it, they are believed to exist in what? They are believed to be arranged around their nucleus in a position known as the electron orbit or electron shell. So these are the shell. This is the first quantum number. As I said, this is the second quantum number. This is the third quantum number, and this is the fourth quantum number. So these electrons, they are believed to be arranged like this. So this is the first energy level. This is the first energy level. This is the second energy level. So these electrons, they are believed to be arranged that way. So the electron is always held by a force. So each of the electrons here is always held by a force of attraction between the electrons and the nucleus of the atom. So they are always held by a force called an electrostatic force. So this force always holds the electrons. This force always holds the electrons in an atom. So these electrons in an atom, the energy of each of these electrons is always related to the distance. For example, these electrons that are very close to these electrons that are close to the nucleus here, for us to remove these electrons, a lot of energy is needed. Are we together? A lot of energy is needed to remove these electrons from the atom, compared to electrons that are, let me say, they are far here. You don't need a lot of energy to remove electrons that are far at this shape. The reason is because the force of attraction, the distance between the electrons at this point and the nucleus is very far. So as a result, just a little effort, just a little energy can remove the electron at here compared to the one that is at this point. So the energy level of each electron always depends on how far or how close it is to the nucleus. So the electron is always held in its orbit by the force of attraction, is always given by the relation H. This is the relation. This is the energy. Is always given by, this is the symbol of the energy of each electron. Is always given by energy is something as minus the Planck constant multiplied by the speed of light all over the quantum number, all over the square of the quantum number multiplied by a constant known as a rhythmic constant. So this is the relation, this is the energy. Each electrons that exist in an atom always have an energy that is given by this formula. Energy is something as minus hc all over m square divide all of hc multiplied by r, which is the rhythmic constant, divided by m square. Our m here stands for the quantum number. This is the quantum number. What exactly is the energy level of the electrons in the shell? Are we together? So this c stands for the speed or the velocity of light. This is a constant. It's known as a rhythmic constant, which is given as r is something as 1.097 times 10 raised to power, I think 7 per meter. 7 per meter. This is a constant. So each of the electrons have this energy level. So we can represent this energy level or the orbit of an electron horizontally like this. We can represent it horizontally like this. We can represent it horizontally this way. Assume that this is the first energy level. This is N1. First quantum state, sorry, N1. This is another one. This is another one. So another one. This is N1. This is N2. This is N3. This is N4. And this is N5. So the energy level, this is the ground state. We call this one the ground state. That's the level, the shell that is very close to the nucleus. So these are the energy levels of electrons in an atom. This is what we call the ground state. And what we mean by the ground state is the most stable state of an electron. This is the state that the electron is very close to the nucleus. So this is the second energy level. So continuously like that. So using this formula, energy is something as minus h CR all over n squared. where our H here stand for the Planck constant, which have a value 6.6 times 10 raised to power minus 34 joules, and C, which stands for the speed of light, which is set as 3 times 10 to the power 8 meter per second, and R here is a constant known as a rate constant, which is set as 1.097 times 10 raised to power minus times 10 raised to power 7 per meter. So at this ground state, when you multiply this, you divide it by this value n equal to 1 here. You are going to have this value as, you are going to have the energy level at the ground state as minus 13.6 electron volt. So at this stage, this is the energy level of all the electrons that are at the second shell. Continuously like that, when you continue to divide this value by the value of the n, which stands for the energy, the quantum number. So generally, when an atom is heated or bombarded with an energetic particles, its energy is said to increases. So as you all know that these ones, they are negative. So once the energy of electrons at this point, when it begins to increase, this value will begin to move close to, this value will begin to move up very close to the zero. So at that level, you say what? The energy of the electron is increasing. So as the energy of the electron is increasing, as it continues to increase, as it continues to bombard it with energetic particles, as it reaches a particular point, the electrons will jump from a particular level to another one. So the next level that the electron is, we call it what? The excited. We said what? The electron is said to be what? Excited. That's the reason why it moved to the next higher energy level. So because excited states, they are always unstable, because that's not their positions. They are always what? Unstable. So as a result, soon the electron soon jump back to its original state. Are we together? So as the electrons jump back to its what? Original state, it used to emit a photon of light. So based on the work of Max Planck, as I've said, the photon of light that is emitted is always given by what? Energy is set as h multiplied by the frequency. So as the energy leaves, as the electron leaves this unstable state to the ground state, it used to emit a photon. So the photon is given as mathematical as the energy at the excited state minus the energy at the ground state is the same thing as the Planck constant F multiplied by the frequency at the excited state. As you all know, frequency is the same thing as the speed of light multiplied by the wavelength of the light. So when you substitute the frequency F, is the same thing as the speed of light C divided by the wavelength of the light. So when you substitute it into this equation, you are going to have the energy level at the excited level 1 minus the energy level at the ground state is the same thing as the Planck constant multiplied by the speed of light divided by the wavelength, which is lambda. So as the electrons jump from this level to this, it used to emit a photon of light, which have an energy. When you subtract these two, you are going to have the energy of the photons that is given out. So this formula, I think, is the second formula. This is the start. So let's solve an example under this equation. So example, an electron jump from one energy level to another in an atom, radiating 4.5 times 10 raised to power minus 19 joules. If the Planck constant H is the same thing as 6.6 times 10 raised to power minus 34 joule seconds, what is the wavelength of the radiation? We are to take the speed of light, C, to be the same thing as 3 times 10 raised to power 8 meter per second. This is an example. So we are to use equation 1.2, which is same thing as E1 minus E2. E1 minus E2 is same thing as HC all over lambda. So the solution using this equation, change in energy is the same thing as the energy at the excited state minus the energy at the ground state is the same thing as H multiplied by the frequency. So based on the questions, the question tells us what the electron jump from an energy level to another. As it jump, the change in energy is same thing as 4.5 times 10 raised power minus 19, 10 raised power minus 19 joules. Is the same thing as our Planck constant is 6.6 times 10 raised power minus 34. And our frequency, we say is same thing as the speed of light, which is c. And our c is given as 3 times 10 raised power 8 all over lambda. So, when you multiply this, 6.6 times 10 to the power minus 34 times 3 times 10 raised to the power 8 meter per second, and you make lambda, which stands for our wavelength, to be the subject of the formula. You're making lambda to be the subject of the formula. Whatsoever you have as multiplied 6.6 times 10 to the power 34 and 3 times 10 raised to the power 8. Whatsoever you have, you divide it by 4.5 times 10 raised to the power minus 19. I think your final answer will be the same thing as 4.4 times 10 raised to the power minus 7 meter. This will be the wavelength of the radiation that is emitted. That's what the person said. We have to calculate the wavelength. So the wavelength will be same thing as 4.4 times 10 raised to the power minus 7 meter. So I'm leaving you with this assignment. So the exercise. So you do it and you submit it to me to this, my email address. You work on this exercise I'm giving you, so you submit it to me in our next class. You submit it to me through the emails below. So the questions goes as follows. An atom excited to an energy level E2 is the same thing as minus 2.42 times 10 to the power minus 19 joules. Falls to the ground state, which is E0, which is the same thing as minus 21.8 times 10 to the power minus 19 joules. Calculate the frequency and the wavelength of the emitted photon. You have to take the Planck constant H to be 6.6 times 10 raised to the power minus 34 joules seconds. So you submit it to me through this email address, masterdanmusa@gmail.com. So see you in our next class. Have a nice day.